Assalamualaikum everyone. We are starting with the 14th lecture of Algebra, and this time we would be doing some plotting. We would be making some graphs. Now remember last time and the class before that we talked about sketches. So now it's talking about graphs, and we'll be going back to sketches very soon. Now when we look at the syllabus, what do we observe? We observe that this is section 2.10 from the new syllabus for the year 2025, and you people will be the first one. They will be giving this exam of this new syllabus. Some things are added, some things are subtracted. Construct table of values and draw, recognize and interpret graph. So it's construct table of values, then draw, then recognize and interpret graphs for functions of the following forms. So which is the following form that we talk about? Ax power n and ab power x plus c. Now here are some examples. A cubic, a quadratic type of reciprocal function, a power function. So let me write it down. This is cubic, this is reciprocal plus straight line type of function, a mix and match. This is a power function. We went over these separately. And now what about the powers of n? The powers of n could be -2, -1, half, 0, half, 1, 2, and 3. Now what does it mean? Let me explain this. Y is equals to ax power n. So y is equals to ax power n. If n is -2, y is ax -2, which is a over x square. This is the reciprocal square function. If x is -1, y is equals to ax -1, which is a over x. So this is reciprocal square. And this one is simple reciprocal. The inverse function, inverse proportionality. So this is inverse proportionality. This is also inverse proportionality. So we went over these two. Now this one we have not yet studied. What if x is 0? Y is equals to ax power 0, which is simply a. Y is equals to a is a line parallel to x-axis. What about power 1? Y is equals to ax power 1, that is a straight line. The gradient could be positive, the gradient could be negative. What about power 2? This is quadratics. Y is equals to ax square, this is quadratics. And what about power 3? Power 3 is y is equals to ax cube. This is cubic. So these are the different things that we have studied. The only thing that we have not studied is these two. That is ax power half and ax power minus half. So y is equals to a root x, or y is equals to a over root x. This is not yet done. This we have to study. And then this thing, ab power x plus c. So this is like this thing, 2 power x, the power function. So this one is power function. This we have studied, but what is not studied? This thing, the plus c, is not yet studied. So y is equals to ab power x plus c. This is again not yet studied. So these three things we need to study. Now it says solve associated equations graphically, including finding and interpreting roots by graphical methods. This we will study. Solve associated equations graphically, including finding and interpreting roots by graphical method. Draw and interpret graphs representing exponential growth and decay problem. So this is again not yet studied. We will study them soon. Just giving you a sneak preview. That is that when we talk about these things, so the new edition book that you people have, maybe it's going to be book 3 or book 4. So any which one. So these new syllabus books that you're seeing right over here, so they will be dealing with these things. That is the exponential growth, the graphic function, the rational functions, and so on. Coming back over there, not this thing, over here. Then it says estimate the gradient of the curves by drawing tangents. This we will learn. Now, this next one, this we have studied a bit, that is sketching curves. So sketching curves, when we talk about it, we talked about linear, we talked about quadratic, we talked about cubic, we talked about reciprocal, we talked about exponential, and these are the different kind of things that we need to study. What are the different types? This is straight line, this is quadratic, this is cubic plus a constant. This is also a cubic which can be written as x common ax square plus bx plus c. This is not yet done. So this is not yet. This one is also not yet. So this we have to do. We also have to do completing square method. That is not yet done. So the red one is not yet done. Just giving you an overview. And then we have this thing. That is the reciprocal function plus n. That is again not yet done. Reciprocal plus n not yet done. And this one already stated over here, which was written over here. Something like abx plus c. That's the same thing as over here. So this is not yet done. Knowledge of turning points, vertical and horizontal asymptotes. This is very important. This is new in the syllabus. Roots and symmetries required. Find turning points of quadratics by completing the square may be required. So that is already written over here, not yet done. So now let's get started with the sketching part. And let's look at this. That is the first one. It says, draw the graph of y is equals to x square minus 3. Now we will focus on sketching the graph. So draw the graph of y is equals to x square minus 3. So we take some values of x and then we square each of them, and from these values we subtract 3. So these are the y values that we get. So these are the y values. Plot the coordinates and join the points with a smooth curve. So these were the points 1, 2, 3, 4, 5, 6, 7, and 8. So there are 8 points over here. And we join them. Actually, there should be 9. And there is also one over here. 1, 2, 3, 4, 5, 6, 7, and 8. And this is the 9th one. Now, what you see over here is symmetry. What you see over here is symmetry over here, over here. So, because 0 is giving me negative 3, minus 1 is giving me negative 2, and 1 is giving me negative 2. Negative 2 is giving me 1, 2 is giving me 1. Negative 3 is giving me 6, 3 is giving me 6. Negative 4 is giving me 13, 4 is giving me 13. So in quadratics, let me write down a point. In quadratic curve, there is a symmetry. So there is a symmetry about the turning point. Turning point, that is TP. It's also known as vertex. So that means if I draw this line over here, which is already drawn, this graph is symmetrical. So let me focus on the point. This value and this value, they have the same height below or above the x-axis. These two have the same height. These two have the same height. And these two have the same height. So that is what we mean by symmetry. Now, how would we calculate this turning point? That we will study, and that will be part of completing square method. So at least 3-4 classes will be there in order to complete all these things. This thing is done. Now just acknowledge on the WhatsApp that whatever we have studied so far, whatever we discussed so far, everything is good and everything is clear. The thing about the syllabus, the thing about the plotting. First, we will go over these sketches and then I'll ask you people to draw something. I've already shared the PDF with you, so you must have taken out the printouts of that. Okay, now let's move on. Now what does it say? It says draw the graph of x square plus 3x minus 2. So this is x square plus 3x minus 2. Again, this is how you fill in the table. Of course, you can just plug in the value in your calculator, plug in a value, fill in the table. In the exam, most of the values will be filled up. 1 or 2 will be left for you. So negative 4 is giving me this value and so on. And this time, you also see a symmetry. Now I'm focused on the symmetry thing. This time you see that these two values are the same. Then these two green values are the same. Then these two red values are the same. Then this value should right be over here. It's not drawn yet. That is negative 5. That is the same. And if the curve were to go this way, like this, then this value and this value would be the same. This value and this value would be the same. But it's not drawn. Now this point over here, negative something. If I draw this line, so I think this is too thick. So now it is symmetric about this line. Can you see the symmetry? The line symmetry? It's symmetric about this line. That means this x coordinate over here, negative 1.5, if I'm not mistaken. So x is equals to negative 1.5. That's the x coordinate of the turning point. Over here, 0, x is equals to 0 was the turning point. So the vertical line, this is the line of symmetry. So this is, excuse me, line of symmetry, and it passes through the turning point. This is again the line of symmetry and it's passing through the turning point. Naturally, we have to study completing square for that. Another graph, a cubic graph. Now this cubic graph, we plug in values of x. Let me just highlight this. So we plug in values of x, and these are the corresponding values of y. And when we plot it, what do we get? We get the shape like this. It's going like this. There is no line symmetry over here. When later on we will study rotational symmetry, that means if I have a blade like this, let's say this is A, this is B, and if I turn it around, so it would be like this, B would be down, A would be up. That is called rotational symmetry. Like if you're sitting in your room and you have the fan on, and if it has 3 blades, so that's the one blade, not a very good nice drawing, that is one blade, then another blade like this, and the third blade like this. So this is A, this is B, this is C. It will take 120-degree rotation to go from A to B and then B to C and C to A and so on. So after 360 degrees, 3 rotations, it will be at its place. So that's the kind of rotational symmetry that this curve has. I just want to pinpoint how to plot this curve. Over here, simple reciprocal but with a movement. Find the equations of the asymptotes of the graph y is equals to 2 over x minus 2. Use your answer to sketch the graph. Now, what we will do over here is that we will apply a method. Right now, let's say if there is a table of values, so we will draw a table of values and plot it. The main thing that we observe over here is that look at this number, negative 2. Look at this thing, that is negative 2. That means y is equals to negative 2 is the line which the graph does not touch. So that is y is equals to negative 2. So the graph gets very close this way to the line. It gets very close this way. We are focusing on plotting, but the sketching is not yet done. So sketching will be coming up in the next classes. And last but not the least, that is the square reciprocal. Again, we have a line of symmetry over here, something like this. That's the line of symmetry. And we just plug in the values over here. So these are the x values, these are the corresponding y values. We just plot it and we get the graph. So now these are some of the things that we need to draw. Now let's go to some past paper questions. It's a combination of paper 1 and paper 2. It says the graph of this cubic is drawn on the grid. By drawing a tangent, estimate the gradient of the curve at x is equals to -1. Now what is a tangent? A tangent is a line touching a curve at only one point. Only one point. It's not cutting the curve. Now when we say x is equals to -1, x is equals to -1 is right over here. So let me grab a line like this. No, this is not a tangent. Let me go back. Now this is a tangent, but it's not touching it properly. So let me go back. I just need to use this line. I think this will be better. Okay, now that's a good one. Not a very accurate one, but a good one. So that is a tangent. Now why it is not a very good one? Because this image at inclination and this inclination is slightly bit different. So let me just draw a line like this. Like something like this will be the best one. I missed it. Okay, I think that is pretty good. So now this green line is the tangent. At this point, x is equals to -1. Estimate the gradient. Now first thing first, that is a curve has a variable slope. It has a variable gradient. Over here, the gradient is positive, it's different, it's different, it's different. So we draw a tangent and we estimate the gradient at a particular point. I'll just pause for the azan. So now we were talking about this idea that a curve has a variable slope, a straight line, a tangent has a constant slope. So the gradient at each point is different. So now if I want to find the gradient at this point, what do? I draw this tangent. I draw a line that is equally sloping at each end. So that is a good line. Of course, the examiner knows that there is human error involved. So slight variation will be there and we will look at the answer also. Now let's take any 2 points on this line. So let me choose the point. I think this is -1 and this is 4.8. And let me just, the table is not here. So -1 and 4.8, that is 1 point. And this is 0,2.6. That's the other point. So 0,2.6, that is the other point. Is this thing all good? So I took 2 points on this line and let me find the gradient. So the formula for gradient is change in y, y2 minus y1 over change in x, x2 minus x1. This is from coordinate geometry. Maybe you have studied a bit of coordinate geometry. I haven't taught it as yet. We will soon be going to coordinate geometry. So therefore the gradient is 4.8 minus 2.6 divided by -1 minus 0. So this is 2.2 divided by -1, which comes out to be -2.2, and which makes sense because a line going down like this has a negative slope. Yes, the answer is negative. So let me write negative 2.2 over here and let me find the answer. Tangent drawn, negative 3 to negative 2, that is the answer. Depend on close attempt at tangent x is equals to negative 1. So it all depends on how you would have drawn it. So they have given a range of values which is negative 3 to negative 2. Ours is negative 2.2. That is all good, all perfect. Now another new thing, that is by drawing a suitable straight line on the graph, find the solutions of the equation this value. Now what is the thing that you have drawn? We have drawn this thing x cube over 5 minus 3x plus 2. Y is equals to x cube over 5 minus 3x plus 2. And now we want this thing. So what do we have? We have x cube over 5, that is already there, minus 3x is there. The missing thing is this thing. So what do? Is that we want the solution of this thing. So is equals to 0, that means if I add plus 2 on both sides, this left hand side is this equation. So draw the line y is equals to negative positive 2. Now what am I trying to do? Let me first explain it. This graph is already drawn for us, x cube over 5 minus 3x plus 2. I want to solve this equation. Now how can I solve this equation? Unless and until I make this equal to this, then I would have this y over here. So what was the missing piece of the puzzle? That was this plus 2. I added a plus 2 on this side. In mathematics, if you do justice, whatever operation you do on one side, if you do it on the other, that is perfectly good. So I added plus 2 on both sides. When I added plus 2 on the left hand side, that becomes y. So now this y equals to whatever constant is left, that is y is equals to 2. Now this is the answer. B1 for each, 1 mark for each part. If 0, M1 for line y is equals to 2, drawn at least this much. And these are the answers. That means grab the line, y is equals to 2, and go all the way this way. Now what are the points of intersection? So the points of intersection are this particular value and this particular value. Go down and read of the value. It's not very exact because my line is a bit thicker. One value is this. The other value is the line went astray. So the other value is like this. So now this one is how much? This is negative 3, negative 3.5, 3.6, 3.7, 3.8, 3.9. So this is 3.85. So let me write negative 3.85. And over here, what is that? I think it is symmetrical. This is also 3.85. So this is positive 3.85. So now two answers are there. That is negative 3.85 and positive 3.85. Let's look at the answer. Between 3.9 and 3.8, between positive 3.8 and 3.9. So our answers are 3.85 negative, positive 3.85. Is this all good, all clear? So what have we learned over here? We have learned by drawing a tangent. What do we mean by tangent? We have talked about by drawing a suitable straight line on the graph, find the solution of this equation. So that is the knowledge that we have applied over here, and that is how we used it. So now let's look at this question. It's a quadratic type graph. The variables x and y are connected by this equation. There is a constant, there is an x, there is an x square. Yes, it's quadratic. So keep in mind, you might see some symmetry over here. You should. Then it says some corresponding values of x and y are given in the table below. Now let me first focus on the table. Unknown, unknown, negative 1, 1.5, 3, 3.5, 3, 1.5 and negative 1. I do see symmetry. Look over here, negative 1, positive, negative 1 on both sides, 1.5, 1.5 on both sides, and then we have the red one, 3 and 3 on both sides, and this one over here, That 3.5, that is like in the middle. So now compare this thing. This is 1 unit on this side, 1 unit on this side, and they are giving us the same values. 2 units, 2 units, they are giving us the same value. Similarly, this one, 3 units on the left, 3 units on the right. From this point 1, they are giving us the same value. Therefore, we will be getting the same value for -3 and the same value for 5. You will use the calculator. Let me show one working. When x is 5, y is 3 plus 5 minus 5 square, which is 25 over 2. 3 plus 5 is 8. 8 minus 12.5, which is -4.5. This is -4.5. And over here, we should be getting the same value, which is -3. You plug it in and you can check it with your calculator. I believe in symmetry. Now let's plot this graph, complete the table, 1 mark. Using a scale of 2 centimeters to 1 unit, draw a horizontal axis from -3 to 5. So we have to draw 2 centimeter to 1 unit, draw a horizontal x-axis -3 to 5. Count the squares. This is 1, 2, 3, 4, 5, 6, 7, 8, because 2 units, 2 centimeter equals to 1 unit, exact same thing. So therefore 1, 2 and 3, let me draw the y-axis right over here. So this y-axis will go like this. For the x values, I should draw the proper line, the y-axis. For the y values, 1 centimeter to 1 unit, draw a vertical axis from -5 to 5. There is, I think, more space. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We needed 10 units, total 10 units, -5, +5, and we have space for this thing. So I think if there is 10, so let me just draw in the middle, right over here. Going to the black marker, this is the x, this is the y, this is 0, 1, 2, 3, 4, 5, -1, -2, -3. Edge to edge we are working. And then at 1 it's 3.5. At 1 it is, okay, I need to label this. 1, 2, 3, 4, 5, -1, -2, -3, -4, -5. So at 1 it's 3.5. It's right over here. Let me use a red marker. Okay. And then 0 is giving me 3, 2 is giving me 3. 0 is giving me 3, 2 is giving me 3. Do you see the symmetry right over here? And then -1 is giving me 1.5. So -1 is giving me 1.5. So this is 1. And 3 is giving me 1.5. 3 is giving me 1.5. And then 4 is giving me -1. And -2 is giving me -1. 4 is giving me -1 and 2 is giving me -1. 5 and -3, both giving me -4.5. -3, -4, -4.5, and 5 is giving me -4 and -4. Now it's a perfect quadratic curve. It's going like this. And that is how you can join it by freehand. So let me choose a marker, a green color one. It reaches its maximum. And then I'm turning around my iPad. And do you see how perfectly have I drawn it? Okay, all good, all clear? So another 3 marks for this thing. By drawing a tangent, estimate the gradient at 3, 1.5. So 3, 1.5, let me draw a tangent. Let me draw something better. No. I think that would do the job. So I'll be choosing this 1 point. That's right over here, 3 comma 1.5, and let me choose another point that's right over here, which is 3.5, 3.8 comma 0. So this is 3.8. Let me make the marker thinner. 3.8 comma 0. Gradient, change in y over change in x, y2 minus y1 over x2 minus x1. Draw a line so that you know this is the direction in which you are subtracting. So this is 0 minus 1.5 divided by 3.8 minus 3. This is 1.5 divided by 0.8. So I can use a simple phone calculator for this. So 1.5, hold for a second. This comes out to be 1.875. 1.875, that is the answer. Let me first double check. Minus 2.4 to 1.6 depend on the tangent drawn. So ours is negative 1.875. That is perfect. Now let's look at this. The point of intersection of the graph and the line y is equals to k. So the graph was drawn in green. The point of intersection of this graph and the line, let me choose this color, y is equals to k, are the solutions of this equation. Find the value of k. Now another way of asking the same type of question. So what we do is that we equate the two. 3 plus x minus x square over 2 is equals to k. Simplify. So let me multiply by 2. So 6 plus 2x minus x square is equals to 2k. And let me take 2k on the other side. 6 plus 2k, that's a constant, plus 2x minus x square is equals to 0. If I compare with this, compare coefficients, what do I observe? Minus x square, positive 2x. Instead of 10, what do we have? 6 plus 2k. So 6 plus 2k is equals to 10. 2k is equals to 4. Therefore, k is equals to 2. Therefore, find the value of k. That is k is equals to 2. Do you get this idea? Both equations combined, made into one equations, that is the same answer as this. So the rule is if two equations are intersecting with each other, that is the same thing as one curve intersecting the x-axis. That is the logic that we use over here. So by drawing the line y is equals to k on your graph, find the solutions of this equation. So draw the line y is equals to 2. So let me draw this line y is equals to 2. I think I've already used this color. So let me choose some other color. I have drawn the line y is equals to 2, and what are the values that we are getting? We are getting this value. This is, why is it overlapping? I don't know. Some issue. Okay, so now this is, let me just erase this thing. This is like this. Okay, so let me just draw a line. Okay. So this is the x-axis, that's the y-axis. This is -1, this is -2, this is -3, this is 1, this is 2, this is 3, this is 4, this is 5. Now this is one point of intersection, which is this is approximately -0.7, and the other point of intersection is this one, which is 2.7. So I think -0.7 and 2.7, -0.7 and 2.7. So this is -2.7 and 2.7. I think that is some issue. I think the overlap is there. So this is 1, this is 2, this is 3. and this one is y is equals to 2.7 and negative 0.7. So that is the answer that we are getting. And let's look at the solution. The sketch is part of the graph y is equals to pa power x, where a is greater than 0. The curve passes through the point 0, 4 and 2, 36. Find the value of p. So this is like simultaneous type. Y is equals to pa power x. When x is 0, y is 4. This is p a raised to power of 0. 4 is equals to p a raised to power of 0 is 1. Therefore, p is equals to 4. Find the value of a. So now plug it in. Y is equals to 4a power x. Now plug in x is equals to 2 and y is 36. This is 4, a is 2 power x. So this is 36 divided by 4, the value of p a power x. So we are looking for this thing. It's right over here. This a is unknown and x is 2. 9 is equals to a square. 3 square is equals to a square. Therefore, a comes out to be 3. So p is 4, a is 3. P is 4, a is 3. The graph passes through this point. So now we have this whole equation 4, 3 power x. Now the graph passes through this equation. When x is 4, y is q. So q is 4 into 4. This is 3 raised to power of 4. This is 4 into 81. 4 into 80 is 320, 324. So 324 is the answer. That's the answer for this one. So that's how this question is solved, and that completes our lecture number 14. We will continue with this in the next class. Take care.